It's a bird. It's a plane. Nah, it's just some fish frying. Hey, everybody. Welcome to this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and hosted by you know who. Yep, that'd be me, Amelia Dalton. Folks, I have 3 words for you: printed organic electronics. Yes. My guest today is Dr. Florian Ullrich from InnovationLab, and we are talking about this very thing. And we're talking about the first fully printed rechargeable batteries for flexible printed sensors. Can you tell I'm excited? I am. All right, let's go. Hi, Florian. Thank you so much for joining me.
Hello, Amelia. It's a pleasure to be here. It's great.
Great. So first off, for my audience who may not know, what is InnovationLab all about?
InnovationLab is all about printed and organic electronics. So I think this is definitely the core of what we are doing. And when I talk about printed electronics, it's certainly not 3D printing, but it's rather related to printing technique that you all know. There are different standard printing techniques. We modify them in a way that we can print also electronics. And organic electronics, it's not, let's say, about bananas that we make shine or glow or something like this, but it's related to organic chemistry. So it's related to materials which have carbon compounds in this sense. And we are a company, we develop new products and bring them to the market. Originally, we come from the research. So we have been founded as a research cluster in the field of printed and organic electronics. There were a lot of companies, a lot of universities also involved, and the idea was to make cutting-edge science and then transfer the results from there into product and bring them into the market. And over the years, the focus has shifted more and more into the development and to the production and less on the science. But we still do science, but the focus is definitely on the market.
Okay, so let's dig in a little deeper. My fellow editor here at EE Journal, Max Maxfield, wrote a really interesting story about your printed organic electronics recently. But for my audience who didn't have a chance to read his article, tell me more about your electronics and the innovation behind the printing technology.
In general, you can print all different things, which you know is the graphical printing, of course, for packaging and everything else. Also, in the functional printing, there are many things that you can print. So let me start with the sensors, because this is our background and this is what we focus on. You can print all different types of sensors. For example, pressure or force sensors, temperature sensors. You can also print gas sensors, biochemical sensors, capacitive sensors for touching, sliders, for example. So these are just to name a few. So there are several big plus points why to use printed electronics and not conventional. One is the area. So we can print on very large areas and still have a very thin thickness. So we can print on foils, and this makes application accessible, which are usually not addressable. I will give examples later on. For example, in battery packs, there's not much space. You just have some microns, and there you can put these spatial distributed sensors into it. So this is certainly one of the main aspects, the flexibility and the thickness, the aspect ratio. And furthermore, you can embed these into systems. You can also print antennas, for example. You can print solar cells, LEDs, lighting techniques. You can print things for generating energy, like thermoelectric generators. You can combine these things in a very, very broad sense just by printing techniques. And maybe I should lose some more words to the printing techniques just to get this clear. Printing techniques are, for example, inkjet printing. This is what everybody knows from the office jet at his work or at his home. So you have small cartridges, you know them, they have small holes in the bottom and droplets come out of that. And what you have there are these graphical inks, but you can use functional inks instead. Let's say those that are electrical conductive, silver, for example, or copper. You can also print gold if needed, and also semiconducting inks. Other techniques which you may know is screen printing. This is usually used for printing on textiles, for example, like these big logos and whatever. And this is a very, very broad and commonly used technology also in the functional printing technology. Then there's flexographic technology. And so there are many technologies, and they are not new by themselves. But what one does when you want to print functional is that you take this conventional printing technique, you modify the inks and the printer, and then you're ready to go.
So you guys just partnered up with Evonik to produce the first fully printed rechargeable batteries for flexible printed sensors. So Florian, tell me more about these batteries and how are they different from traditional batteries? What benefits do they bring to the table?
So first of all, Evonik did a really great job during the last years to develop this material system. So they are the experts for the materials. We are the experts for the printing and the scaler, for the design of the batteries and so on. And when I compare them, maybe let me start comparing with what has been there on the printed market already, which is printed batteries. You can get them already. The technology is there, but not in a rechargeable way. And of course, this has benefits when you don't want to throw your thing away after you have used it and the battery is dead. So in this case, you just can recharge it. And this already touches another huge benefit, which is you can, as I said, you can combine them or print them into bigger systems. For example, you can combine it with a printed antenna. And with this antenna, your wireless charging from your phone or whatever, you could also use it to recharge the battery. And this in a very cheap way and highly effective way for the manufacturing. So the antenna can directly print it next to the rechargeable battery. And then compared to conventional systems, the benefits are the same benefits as for most of the other printed and flexible electronic things, which is it's flexible and it's lightweight, can be put at spaces where you don't want to have or cannot have thicker things. For example, also in the field of medical wearables, just imagine a smart patch which you stick onto your body at a certain point. You don't want to have a thick battery which is hanging around there. But if you could replace this with a very, very thin patch, you maybe don't even notice it afterwards. The capacity of these batteries is not yet very high, but for many applications, you don't need such a high capacity. So it's enough the energy is enough to do some of the measurements, store some data, and then either you can read it out afterwards or just send it out every now and then wireless connection. Yeah, and furthermore, it's a solid state, so there are no liquid electrolytes, for example, in there. This cannot leak out of a battery and then burn, for example. And the materials are not poisonous. They're all on carbon-based materials. So this is another strong benefit.
All right, Florian, let's talk about high volume production. Can you explain what roll-to-roll means and what exactly is special about InnovationLab's machine? And can you explain a little bit the role Heidelberger plays here?
First question, roll-to-roll. Roll-to-roll means that you start with a roll and you end with a roll. So the substrate is rolled up onto a large roll that can be several kilometers in length. And you put this into the machine, you run it through, you have several stages for printing. And then in the end, you also have a roll again with a functional print on it. Maybe you have an image in your mind from the printing of labels or on newspaper, for example. It's very, very high throughput. They come there very, very quickly out of it. And this is basically the very same. It's indeed very, very much the same because our machine is actually a label printing machine. It has been designed for the printing of labels with a very high throughput. So the maximum velocity of our machine, with this velocity, we could print the whole height of the Mount Everest within only 1 hour. So it's 160 meters per minute, a very high speed. But this is not the velocity with which we can print right now, admittedly, but it's enough to print several kilometers each day with our machine, which is still, if you think about sensors size of let's say a finger or something, this goes very quickly to 1 million pieces. So the throughput is still very high. And just to finalize this, the opposite or the pendant to roll is sheet-based or sheet-to-sheet. So you start with a sheet, you put this into your printer, print on it, and you get a printed sheet. This is basically what you know from your office jet. But roll to roll is certainly you can achieve much higher velocities. What is special about our machine is that it's very versatile. So it has up to 5 printing slots, and they can be equipped with all relevant printing techniques. The ones that I said could be screen printing, also flexo, there's gravure printing, slot die coating. So these are different types for those who are not familiar with the printing techniques, different types of printing, and you can do different things with it, let's say it like this. And with our machine, you can combine these different techniques after each other, and you can, with that, you have a highly integrated system and very effective manufacturing process. So you can print up to 5 layers within one run. If this is not enough, you take the roll, you put it in the beginning, back again, and then you print another layers, whatever is needed back then. So I was talking about the capacity, and if our capacity is not high enough, not sufficient for the product, then Heidelberg comes into play. Heidelberg printing machines, or Heidelberger Druckmaschinen in Germany, they are market leader for the manufacturing of printing presses. And usually they sell the printing presses, but in this case, in this business model, they sell the products or the semi-final products. So they have a similar machine than we do, a little bit faster, a little bit bigger, better. So we have help to set this machine up. And this is meant only for the industrial production. So really high throughput production of printed electronics. And the idea is very simple. So once we know how to print a product on our machine, how it runs smoothly, then the product, and also we had the market entry, then the product, the production is transferred to their machine, and they just do the industrial production, if needed, even in the 3-shift manner. So yes, I think these were the 3 questions, right?
Yeah. Okay. So Florian, you guys have a really interesting shareholder structure. Can you explain that dynamic and how it affects the overall company routine on a daily basis?
Yes. So it's special in the sense that we have on the one hand companies, and the other hand also universities. The companies are pretty well known, BASF, also a chemical company. Then we have SAP. I think this is quite well known to everybody. And also Heidelberg printing machines. And from the university side, there's Heidelberg University and the KIT, which is the Karlsruhe Institute for Technology. And this shows a little bit our versatility, that we can do basic research on the one hand, and on the other hand, also try to develop and realize complete systems, complete solutions, and then bring them into the market. And this is pretty beneficial because we have good access to the chemical know-how, and your products will never be better than the chemistry that you use for printing them, of course. So this is really the core of everything. Then you need good printing machines, and also good printers. So this is why the connection to Heidelberg is very important. And then third, we have SAP, because printed electronics plays and will play an even more important role in the future in the field of IoT and connected systems. So they have this huge platform, a very good, well-known platform, Leonardo and so on. So this really helps. And also these companies are customers of us. So we have very good projects, and we can drive the technology to the next level together with these customers. And if needed, we can go to Heidelberg University or to the KIT and do even basic research. So we have this very, very broad bandwidth. And this is, I think, as far as we know, in this sense, unique.
So speaking of research, I know your team is working on a lot of really cool research projects right now. Do you have any favorites you'd like to talk about?
Yes, of course. There are several favorites I do have. One very nice project, I would say, is a so-called smart carpet. This is a carpet of a size with 1 square meter and has about 10,000 pixels, so pretty high resolution. And when you walk over it, first you can see on the heat map the pressure distribution of your foot. This is pretty nice and was also nice in the past, but of course, there's no direct benefit from that. So therefore, what we did is we used artificial intelligence, deep learning algorithm to analyze these patterns. And now the smart carpet can detect that there is a foot, and also the direction of a person that is walking over it. So we use it as a people counting. You just put the smart carpet into the entrance, and then people walk over it, and you exactly know how many people are in my room or in my retail store, in my office, in my building, or whatever. And it's completely anonymous. You don't have to install a camera that sees you. This is, in some countries, it's more important, of course. In other countries, it's less. But in Germany, for example, this is very much important. You don't want to be monitored all the time. And with that, you just walk over it, and the carpet knows that there is somebody in the room. And the smart carpet is even able to distinguish between a person and a shopping cart that is going over it.
Wow. That is really cool, Florian. All right.
Thank you. Yes. Yes. So if I have the time, I would also talk about another very nice application, which I mentioned in the beginning. That is the smart smart as well, but actually battery health monitoring system. This is with pressure distributed foils, so foils that measure the pressure distribution, similar than the smart carpet, but of course in another size. And you can put them into battery packs, so at different spots in your battery pack, and then you see if a battery is deforming at a certain space.
Wow.
And this helps to adjust the management accordingly. So I'm not the expert here, and we're not doing this by ourselves. I'm just been told by our customer that you can have another control to the battery. So you would charge another cell differently, for example, when you see, okay, this is already expanding. And we've been told that with this method, it's possible to prolong the battery lifetime by 30% and more. So 30% longer battery lifetime of the batteries in electric vehicles. So this is really, really huge thing if you could save almost a third of the batteries. And so this is one part with the pressure distribution. Similar thing is going on with the temperature distribution, a flexible matrix of temperature sensors, also something which is not possible in a conventional way, at least not as far as I know, in a reasonable way. And the third thing related to battery health monitoring is that you can also print heaters, like big areas of heaters, which can be integrated there. So if you go to very deep temperatures, the battery will not work properly anymore. So you can use these heaters to heat them up and restore the functionality.
Wow, that is really cool, Florian. All right, so let's circle back to printed electronics. Yes. So printed electronic technology has been around for some years, but real products are rare. Is there a product currently on the market that is being produced by your machines? And where do you see printed electronics headed in the future?
Yes, so it actually is. This is a very nice example on how we work. It's called Oculus Sense because it measures or senses the occlusion. Occlusion is the contact points in your mouth between the teeth in the upper and the lower jaw. And usually it is measured with a so-called articulating paper, very thin paper with wax on it. You bite on it, you chew a little bit, and then the wax is transferred from the paper to the teeth. You may know this from the dentist.
Yes.
Yes. Correct. Good. And then some years ago, a company came to us and they wanted to make this articulating paper digital. So they are called Bausch. They are, at least in Europe, they are a market leader with far than 90% of the market share. So they produce this articulating paper and they want to have it digital. So therefore, over the course of some years, we developed it. And right now, this has more than 1,000 pixels on a very small area, and you can measure the pressure distribution in your mouth digitally.
Wow.
This is a thin foil. I mean, in the podcast, I cannot show it, but feel free to look it up, Oculus Sense. You have this thin foil. This is single usage because not because the foil would be damaged, actually, but rather because the wax will be gone after a while. So you have this sensor foils, you put this into a handheld device with the electronics. This is, of course, reusable. And this device reads out the data from the sensor foil and then transfers it wirelessly into a cloud. And you can read it on your tablet or whatever you want to use. And then you can store and analyze the biting process. So you have a real video of the biting process. You can see the pressure distribution. Is it more right, more left? And also identify points with a very, very high pressure. And so this is pretty successful. has already been sold in more than 60 countries worldwide. And only last year, we have been printing about 1.3 million of these pieces.
Wow.
Yes, and actually, we just maybe to add this, we won an award. We are really, really proud on this and happy about the selection from the LOPEC, the OEA. This is the Organic Electronics Association. So we won the award for Best Product Demonstrator.
Nice. So, Florian, last question for you. Where do you see printed organic electronics headed in the future?
So our feeling, and this is also pretty much backed by market analysts, is that the direction is going towards logistics and medical wearables. Smart patches like, for example, logistics may be temperature tracking. Temperature could be damage detection, could be shock, for example, smart labels which you put onto the package. And then you can see if the cool chain, for example, was correct. And this, of course, you see in the current days during COVID-19 for the vaccination, this is just one application for this. And medical wearable, yes. So you can measure so many different things at the body, whether it be heart rate, respiration rate, but also different biochemical sensors, and then also for diagnostics in the future. So I think these are markets which are evolving very, very rapidly at the moment.
All right, Florian, it is time for your off-the-cuff question. Now, since you haven't been on my show yet, here we go. So we've been a bit in quarantine these days. It seems forever. A lot of places have been closed. You certainly can't travel as much as you used to. But if you could have one meal right now, it doesn't matter if the restaurant's closed, you need a passport to get there. It's on the other side of the world. What would you have?
Well, I really enjoy two things came to my mind. One are the pancakes of my grandma, and the other thing is burgers, but vegan burgers, because I really recommend trying this plant-based food for yourself, for the environment, and also for the animals, and also it tastes very, very good.
Excellent. I love it. Well, Florian, I think that's all I have time for today. Thank you so much for joining me. This was super cool.
Thank you as well. It was a real pleasure to be here.
So if you want even more information about InnovationLab and all the cool stuff they're doing, I would highly recommend that you check out a recent article by EE Journal editor Max Maxfield called Organic Printed Electronics for the 21st Century. And you can check out this article by clicking the link below the player on this week's fish frying page on eejournal.com, or navigate on over to the articles tab at the top of eejournal.com. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter, you can monitor our tweets at EE Journal TFM. And don't forget, if you want to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular EE Journal Chalk Talk webcast series hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's fish frying page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you want any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's fish frying page. Thank you everyone for tuning in. If you know of any cool new technology, or heck, you just want to chat, I promise I will respond. Shoot me a line at amelia@eejournal.com or post a comment on our forums on EE Journal. For the week of April 23rd, 2021, I'm Amelia Dalton, and you've been fried.